Hello and welcome to this Cloud Runner demo. In today's demo, we will use DynamoDB in AWS Lambda. What is covered? First, we will explain what is DynamoDB. You can guess it is a database, but let's take a bit closer look at that. Then, we will use an AWS Lambda function that invokes a DynamoDB table. For that, we will have a SAM template that contains the resources that are required to execute this task. Then we will read an item via GET-REQUEST, and we will create and manipulate database items. What is required for this demo? First of all, you need an AWS free tier account. You need the AWS SAM command line interface installed on your computer. You should have a code editor, command line tool, and an HTTP tool of your choice. And for this demo, some basic knowledge is required. First of all, you should be familiar with the AWS Web Console. I already mentioned SAM. So it is very helpful if you know what is AWS SAM. We discussed SAM in the previous Cloud Runner demo video. Maybe you take a look at that if you're new to SAM. Ideally, you have some basic Python knowledge already, but it's not really a requirement. What is DynamoDB? It's a service provided from Amazon Web Services. And you can say it is a key value database, while a value or a set of values can also be a document. So it is not only a single set, a vector, like in a relational table, it can contain documents finally. You could also name it NoSQL. What is the popular term for all these kinds of databases? DynamoDB is serverless. As we talked in the last demo about Lambda, Lambda provides functionality that is serverless, that is started on demand without requiring any middle tier or a container resource that needs to be started or stopped. So DynamoDB is the same. It's a completely serverless database. So that means the user gets charged for per request and not for just running a database. It is considered to be fast. So there are large organizations running applications with DynamoDB that have millions of users. And it is scalable. So auto, why is that? Why is that auto? It means it's under your control how many resources, how much you want to provide to DynamoDB resources if they are invoked from your application. So it's fine under your control. And you might say, oh, this is a database for millions of users and requests, obviously. Is that for me? Well, it scales from 0. So if you have a small application, that means just a few requests. So that means even small charges. Very interesting concept, I think. DynamoDB offers concepts, of course, for backup and restoring data, and it integrates with other AWS services, serverless services like Lambda. So we will use Lambda to create a web service that reads and writes to a DynamoDB table, but it's even working the other way around. So that means if you manipulate data in DynamoDB, such an action can trigger business logic in AWS Lambda. So even in the relational database world, you would call that a database table trigger that we have here. Like in the last demo, I want just to give you the warning: if you use AWS free tier, that doesn't mean that no charges at all can occur. If you define resources that are not free tier eligible, that could lead to significant charges. So be careful, monitor what you are doing. Set up a billing alert with your AWS account that you know you reached a certain boundary. This demo, though, with the objects we create, the resources we use, causes no costs on top of your free tier limits. Now, let's start with our hands-on demo. But before we do that, let's take a look at the involved components and how they interact with each other. There is the Lambda function with the Python handler app.py and the GET request. We already know that from the SAM Hello World template. This demo just extends that template. We need to add more API gateways to invoke HTTP methods for insert, update, and also delete data. Also part of the template is the definition of the DynamoDB simple table. Last but not least, with DynamoDB, we bring a new player into the game. We need to make sure that the permissions are set correctly. Now, let's take a look at the code. When we call SAM init and choose the SAM Hello World template, we will get a file and directory structure, as you already may know from the first demo. In the template YAML file, we get some resources predefined. The first one is our actual Hello World function. That is a serverless or Lambda function that has the Lambda handler. We have a Python implementation here for our Lambda handler, and the handler itself is in the app.py file. We'll take a look into that. Tied to the function coming with the template is an API event that is triggered by a GET request, actually. So, but for our web service, we don't want to just issue a GET request. We maybe want to manipulate data, want to insert new data into our DynamoDB table and manipulate, like update or delete them. So we create 3 more API functions here. Each of them does a different HTTP method. So we have one for post, one for put, and one for delete. As well, in our template YAML file, we define our DynamoDB table as an AWS serverless simple table. As the name implies, this is the simplest table that you can possibly create here. It doesn't even need a name. So you see here is the properties section. We provide a table name. If you don't provide a table name, it will work. You will get a generic name, but that is not very good. So I think it's better to create a table name. So we have this here. Another thing that we need to do in our template, think about the permissions so that our Lambda function has access to DynamoDB. We have to add a policy here. This is the policy Amazon DynamoDB full access. As the name implies, this policy grants full access to all DynamoDB objects to the function. This is for real world scenario where you have security awareness. This is a bit much. We just do that here to get started. in a real world scenario, you would likely define your own policy that is more granular. Before we look into the implementation of our Lambda handler in the app PY, let's deploy this template and see what we get. You may remember with the SAM commands build and deploy guided, we can deploy our stack to AWS. Now we have done that, and it's a good idea to take a look at AWS Web Console to see what we got. So first, let's take a look at the Lambda resources. And here's our SAM first Lambda Hello World function that we have deployed. The function is here. You see we have our API gateway and we have our 4 triggers, each of them tied to an HTTP method: delete, post, get, sequence, and put. That is here. And here's the actual function. But what about our table? We can go to the DynamoDB section and look into the tables. And yes, here is a my DynamoDB table. Remember, in the template YAML file, this is the simple table that we created, my DynamoDB table. And it is here. Let's take a look inside. We have an overview, and here are the items. We haven't any items in the table. So how does that work? Because we haven't actually defined any structure. So if we do that, we will get a default key, because in a simple table, each item must be identified by a key, and the key's default name is ID. We can create a new item. It will be prompted to provide an ID. Now let's say we want to provide something like a table with persons that we want to remember. So maybe we have something like first name as an attribute, and we name it George. Yay, here's our very first entry in our DynamoDB table. Let's do another one. Let's create another string here. So we have to say, we have to do that again, because the table actually doesn't know anything about a structure. Let's get another one here. ID number 2. Save. Well, and now maybe we think, okay, this is a bit not sufficient. Let's maybe do a bit more. So we have a first name. Oh, come on. But maybe this is not enough. Maybe we want to store also last name. Let's do it like this. Oops. What is this? Oh, okay, I forgot the key. Of course, the key is mandatory. So what that tells us, we don't have to define a table structure ahead. We can introduce new table attributes or columns when we create new table items. That is pretty new. We don't know. I was actually surprised when I learned about NoSQL databases, how this works. This is quite different from what we know from relational tables. But We have our DynamoDB table and we have created some entries. Now, let's get back to our Lambda function and see if we can get these entries back. Here you can see our Lambda handler in the app.py Python file. And what is it doing? First, we extract the actual HTTP method from the incoming event parameter. Remember, when you use a different trigger to call the Lambda function, we use an API gateway function that is an HTTP request, but you could also use a CloudWatch event or something else. Then you won't have an HTTP method here in the event. You had to do something different, but our Lambda function is supposed to be a web service function, so we are sure it's called by an API function, and we have an HTTP method. Next, we create a handler to our DynamoDB database and a handle for our DynamoDB table that was called my DynamoDB table. Then it's always suitable, especially for testing and trying to add some logging. I print the complete event here, as you can see, just to get an impression what we have in this event. I think the AWS documentation is not so very specific at that point. Then we print out the method that is get initiated, and we have an else-if structure to branch to the actual HTTP method to subroutines. The get subroutine extracts a p key parameter from the HTTP request, because if we want to read an item from our DynamoDB table, we have to identify it by the key. Remember, the key was actually named ID by default for a simple table. We have a method for the table getItem, and we do nothing more than print out the item to the response of that HTTP GET. Now we can try it out. We have our HTTP tool up and running. We have our endpoint set up correctly. We have our parameter p key. Let's put in number 1 that we used and initiate the GET request here. And what we are getting is our first record. That was George. Let's quickly check. Yes, that was it. We can do the same thing. Number 2. We will get Paul, and number 3 was likely Ringo Starr. Here we go. So that works. Now, of course, we want to know how can we possibly create new records with our web service. Let's do this next. You may have recognized the way that we get an item with our web service is not really following the RESTful conventions the way we do it with the parameter, but we just want to demo a simple web service that performs DML operations and maybe create a full RESTful service later on. In a RESTful service, inserting of a new item would be associated with the post HTTP method. So we use that here for inserting. In the Boto3 SDK, insert is associated to make a bit of a confusion with put item, with the put item method. We use it, and as an argument, we provide pretty much the body of our HTTP method that will do it. We will just see it in a minute. One more interesting thing is this setting here, condition expression. The put item method would override an existing record if you provide a new record with the same ID. This is not the usual case if you deal with relational tables that have a primary key. You would get a primary key violation. You're always sure that you can never insert or overwrite a record that you already have. The override can come in handy in some cases, but let's stay with the rule. Once you have a record identified by an ID, you don't want to override it. To make that happen, you can state a condition expression here that says attribute not exists ID. That means we can only insert a record where the ID attribute is still not existing. If that all works, we return status code 200 for success and the response. One more thing about logging and exception and debugging. Of course, if something goes wrong here, it would end up in the log file, but the AWS log files are asynchronous. It can take a while, it can take a few minutes until the log entry is showing up of your recent attempt. So I'd always recommend, at least for testing, debugging, trying out, to print the error message to the response of your request. Then you have it right away. So we have the logger here, but we also put the error message to the response of our request. Maybe for security reasons, that wouldn't be recommended for a production environment. You don't want to have your services to be too chatty about what's going on behind the scenes. So you will likely switch it off there, but for any development and trying, this is definitely a good idea. But now, enough talk. Let's try it out. I have prepared our REST tool for the post request with the correct endpoint, and I have a body here in JSON with the attributes last name, first name, and I provide an ID that is not yet occupied. Let's send this guy. Okay. We got HTTP 200. We get a response here. Looks like everything's okay. Let's try it again. So I've sent the same record again with the same ID, and we get an HTTP 403 back, and we get a message. So that's why I'm saying it's always a good idea to make your service transparent in some way. Error occurred, conditional check failed exception, conditional request failed, and this is because of this condition. This condition here was not fulfilled, and that protects our primary key entry. When we take a look at our 4 records that we have inserted in our persons table, and we know who these persons are, we will see, if we really know, there is a bad misspelling here in record number 3. So it's time to update that, to make that correct. Before we do that, let's take a look at the code. So an update in web services is usually associated with the put HTTP method. So we have the do put routine here reacting on a put HTTP request. And finally, we call the table update item method. But to update an item, there is a bit more required than the simple body with the structure we want to insert. So we need the key, of course, to identify the item that we want to update. We have to bring in an update expression. We have to fill in the values that we actually want to update. And it is suitable but not required to get something back. We can, for example, say, please return the updated old values that were originally in the item. So I've prepared our put request here. You can see I provide the values, the attributes that our program wanted to. I provide the key. Key number 3 is for Ringo Starr. And I say set last name. So this is my update expression. I have a bind variable here and I set the right name with $R. Let's execute this. Okay, we got an HTTP 200 and we wanted to get the old values back. So that's happening here. You see here we get back the star with 1 R. We replaced it with the right spelling with the $R here. So that has worked. So we have created an update. A delete is pretty easy to implement. We just need to provide the key of the item that we want to delete, but we do a bit more. It could come in handy to return the values, all old, all values of the item that was deleted. We could use it to do some history tracking, maybe inserting the old values into a history table. Let's try it out. So I've prepared the delete here, and sadly one of our 4 guys left the scene way too early. Let's delete his record. HTTP 200, and we see we get the old values of the deleted record back. Delete was successful. We can quickly check here in the AWS console. Yes. In this demo, we had our first encounter with DynamoDB. We created a DynamoDB simple table with SAM. We created API gateways for the post, put, and delete HTTP verbs with SAM. We used Python and the Boto3 SDK to process, retrieve, create, change, and remove actions on table items. What can be the next steps? We know our web service was not really RESTful, so it could be interesting to create a real RESTful service. The DynamoDB simple table is limited in functionality. There's much more you can do, especially when it comes to complex indexes. So that could be interesting to see. Or maybe you have an idea, let me know. Then I can just say thank you for watching. Feedback is, like always, appreciated, and hope to see you again soon.